Okay, on this video, I'm going to talk about transforming the graphs of sine and cosine. But I'm going to talk about their connection to the unit circle. So let's look at this circle right here. The unit circle generally starts at the point 0, comma 0. This circle has been translated right 2 and up 3. So the center of this circle is the point 2, comma 3. The radius of, okay, before I say the radius, that's a translation. So it just moved 2 units over, 3 units up. So that would be a rigid transformation. That means we've added 2 to the 0, 0, and then we've added 3 to the 0, 0. So that's a rigid transformation. Now the radius has also changed. The radius of the unit circle is 1. We can see here that the radius of this circle is 4. Now that's a dilation of the circle. So typically the circle would have been right here, all right, centered at 0, 0, with a radius of 1. But we've made the circle get a lot bigger. We multiplied everything by 4. And then we, again, translated it over 2, up 3. So how do all of those things appear over on these graphs of sine and cosine? Well, first off, we can see the radius of 4 right here is the amplitude. So both sine and cosine coordinates got multiplied by 4. Whatever the original x and y coordinates were, now they're a distance of 4 from the center instead of being a distance of 1 from the center. The 2 and the 3 show up in these numbers right here. So because we shifted the x coordinates on the circle by 2, that shifted the cosine graph by 2. And then we shifted the y coordinates on the circle by 3, so that shifted the sine function by 3. So those relationships, 3 and 2, come from the x and y pertaining to sine and cosine on the unit circle. Let's look at how that looks like on our graph. So 3 is the midline right here of sine. So that's the line that goes straight through the center. 3 intercepts here to that midline. All right, so that's every time we get back to this point on the circle and then right to this point on the circle. So that's our midline. Our midline of our cosine graph right through the center is 2. And that's those same points getting through the center on the circle where it hits 0. That's these points here and here. Now, let's look at the amplitude, which is from the radius. So from here to here, from 3 to 7 is a distance of 4. And from 3 to -1 is also a distance of 4. You can see those same distances on the cosine graph here and here. So again, all these changes that we made all relate. So let's just check out this first point here. The coordinates of this point are 6, comma 3. So we can see that our sine graph starts, I wrote 7, but it's 6, comma 3. So we can see that our sine graph starts at 3 and our cosine graph starts at 6. So that's these 2 points here come from this point right here. If we continue going around the circle, pi over 2, this is 2, comma 7. Now we have 7. So we can see that our cosine graph has gone to 2 and our sine graph has gone to 7. We could continue moving around the circle like this. We get to this point here, coordinates -2, comma 3. We're at -2 on the cosine because that's the x, and we're at 3 on the sine because that's the y. And then if we were to get to this point down here, coordinates 2, comma -1, cosine is at 2, sine is at -1. And then continuing around, we would then repeat. So as you can see, all of the numbers and changes that happen to the circle affect the sine and the cosine graphs in similar ways. Each number 4, 3, 2 can all find a connection to the circle and find a connection to the graphs of both sine and cosine.